Hey everyone, it's Kyle with Coding on Chain. And in this stream, Roberto and I take us back to the basics. Using Bash and the Cardano binaries from IOHK, we are going to start creating a Cardano Light wallet. In this stream specifically, we are just creating the wallet itself, generating mnemonics, getting the keys, and all that stuff. We, at the very end, accept ADA for our wallet. Awesome. So if you like this type of content, please like, subscribe, leave us a comment. And if you're an ADA holder, please check out our pools, Lift and Peace. Anyway, let's jump in. All right, so this is going to mainly just start a new series where we're going to explore. It'll kind of start with Lift Wallet, but I think it might be beneficial if we just start talking about like what the basics of a wallet are, right? So we can, talk about mnemonics and the keys. How we generate the public and private keys, and like what an address is, and in the end, just accept ADA. So that being said, we do need to get the correct binaries to do so. So,
all right. Because I just have Cardano CLI. I have Docker file here. Oops. Some bash script I can use for downloading Cardano addresses, CLI, and batch 32. So let me use them. There.
What was it do? Oh yeah.
It seems it didn't work. Anyway, I got what I wanted. Ooh. It seems they changed the URL for this. Let me grab.
So while Roberto is getting the binaries, I just want to, I guess, talk about the best way to get a kind of like suite of Cardano binaries that are all supported with their versions. And it really just comes down to going to the IOHK GitHub, then going to specifically their Cardano wallet repository to the releases. And then if you go to the release page and you scroll down into the assets, you're going to see that they actually have all three OSs there. So if you're on Windows, Mac, or Linux, you can download your given OS compression file essentially and extract out all the binaries. So that's going to have Cardano address, which you're going to see that we're going to use a lot of, Cardano CLI, the node, wallet, and there's a few others like Beck32. That being said, unfortunately, you can't use that on Windows. So there you go. Yeah, you can kind of see them being spit out there. Each OS is going to have some other stuff accompanying it. Like you can see there's like some auto completion files there. And that's really just, I guess, to get them working on properly in the respective OS. Now,
yeah,
what Roberto right now is doing is he's taking these binaries and he's putting them in his Linux path. That way he can just type, Cardano address anywhere on his system, and it knows what it's trying to reference.
Yeah.
You don't necessarily have to do that. If you just pull them down, right, you can operate everything that we're doing as long as you just kind of reference the binary. So
like this.
instead of it just being a exactly, yeah.
I
As long as
moved
you use
it.
the path.
I moved them, but yeah, it's the same for the wallet, for the node. Yep. Okay, so we have the addresses, which is the one we want to start with for generating mnemonics. So Cardano addresses, it's I can put this.
Yeah, no, this is perfect. We can explore the binary a little bit.
So this is a binary. I mean, you can build everything from Cardano CLI, but Cardano address is another binary that helps you to for example, handle mnemonics, generating them and recovering, generating private keys from mnemonics, which is something that Cardano CLI doesn't support. If you go Cardano CLI route, full Cardano CLI route, you will generate private keys, but they will be files that you cannot recover. If you lost them, they are lost, and you cannot regenerate them or get mnemonics from the private keys. So the best way to create your private keys is probably to have a recovery phrase to actually recover in case of disaster.
Absolutely. All right, so yeah, if we go ahead and let's show the help on the recovery phrase generate command, and we can, I mean, you can see what the command is there in the first script, but you know, and you can see that one option of size, right? So, and yeah, the first, okay, so he just went ahead, he's generating some mnemonics. Tell him to stop. Just kidding.
We can brute force now.
Oh man, look at him. We're gonna be hacking a bunch of wallets here.
So first thing is you
go ahead and throw the help command on there, just or the option.
You mean for the generate?
Yeah, there you go. So this is actually one thing I want to point out. So you can see that it only has the size option, and then it just takes an integer. Now it says this is where it's funny, right? Okay, so it says basically, you know, a number of mnemonic words to generate. It must be a multiple of 3. Go ahead and can you execute this with a size of 30? So 30 being, you know, that's divisible by 3. Oh, interesting. I'm not really sure why they say that and not just go ahead and tell you that the expected ones are 9 through 24. So it's not necessarily just divisible by 3, but it is those 6 numbers right there. But yeah, just throwing that out there. I always thought that was funny. But yeah, so you know, that's the first step, right? Is getting that phrase. So I mean, I guess we can go ahead and I mean, we can. Do you want to use the script as is, or do you want to just? I mean,
given that,
scripts.
yeah. I mean,
so we'll share this all these scripts with everybody. So you know, we're gonna do this step by step. Everything will be broken out into every file. We'll make the files themselves numbered so you understand, like, you know, kind of the steps that go.
And I will be executing all the scripts with bash-x. I mean, you will need to give execution permissions for the script, but if you execute them like with bash, passing the script name with -x, you will enable the debug mode for bash. It's very helpful for debugging and seeing what happens whenever you mess it up. So we accept $1, we accept just one argument. We won't do any fancy argument parsing on these scripts because these are just for educational purposes. So we will pass an argument where the mnemonics will be saved by this, by redirecting the output from Cardano address, and we can accept, yeah, yes. Oop.
Look at me. I'm doing something. See, I know Bash. I know Bash.
Okay. So now we
What was I
accept.
about to say about this?
Maybe you wanted to
Cool.
highlight that we don't want to use short length recovery phrases because they are not so secure. I mean,
Yeah,
for example,
very true.
Yoroi.
What I mean, out of the 3 or 6, it was like 9, 12, and 15. Yeah, even like Yoroi, right? Theirs are what, 15 words. So, and then like Daedalus, they go with the max 24 words. So,
Yeah.
yeah, I mean, definitely, go and just keep the 24.
Super secure.
Yeah.
Okay, so let's try with a full path for those mnemonics. I don't like extensions, but this is gonna be a plain file, plain text file, so I will use that. And this is the output for the bash debug mode. As you can see, the exit code is 0, so everything went okay. So we should have here mnemonics. Yay!
Yeah. Another thing you can do, a lot of times, especially if I'm working with Bash, I won't execute anything here. Hold on. Can you? Oh wait.
Make the terminal read write. Can you write now? Yeah.
I can, but
yeah,
okay.
I can see
Right,
it.
I'm looking through Twitch. Okay, so a lot of times what I will do is something along these lines, but it does require you to make a folder. So like wallet name, say 1. That way, it's like you can kind of just group all your stuff together. That's a lot of times really helpful. And let's say you want to use these scripts. One thing you could do is enforce policies. Like we're going to probably make everything parameterized, just to kind of like show the process. But when it comes down to it, when using these, you may want to make sure that you're following certain guidelines and rules. So you may actually go ahead and put in, I'm just going to kind of mess this up for a second, something along the lines of, maybe not this necessarily, but, right. So you're not really passing in the whole thing. It might just be like the wallet name, right? So that way, you're always going to produce the same file with the same extension. You're just going to tell it what wallet you're putting this in. Another thing to be careful though is, and you can put checks in here to make sure that you don't overwrite that. So if you do put in the same wallet name, you don't want to overwrite the mnemonic. That would be very scary and bad. So you could always add checks to make sure that you're not doing that. All right. Anyway.
Yeah, and given that we are in Linux system, I would like to point out that you have a couple of different directories where you could store these user files, which are .config. For example, here you can see that Brave, Chromium, Daedalus host their files. Here in Daedalus, for example, you have the cache for whatever, session storage, which is part of the, I guess, for the Chromium that is run along with Daedalus. And yeah, so probably we would like to have here bash like wallet there, where where we will store like. Okay, so let's call this wallet still, and it will be this character actually means home directory. So we could have wallet name will be our first argument. So we can build the wallets dir, and then wallet dir will be wallets dir dash wallet dash slash wallet name. We need to ensure that it exists. So we this argument for make dir command ensures that the full path exists. I mean, if wallets dir does not exist, it will create it and then create the wallet name inside the wallet dir. So for example, if I do tmp blah 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 whatever, it created all the levels at one time. So then our mnemonics private file will be wallet dir mnemonics private. This could be here. There's arguments. Let's leave this like this. So yeah, that will allows us to have a dedicated directory on the dedicated config dir where applications should store their config and data on Linux. Generate our mnemonics there. Shall we try?
Perfect. Let's do it.
So argument number one, it's wallet name. I love puck. Mnemonic size. Let's see if it stored it. Cool. Got it.
Nice. All right. So there we go. We're now generating a mnemonic for our POC wallet. Okay, so let's see. Yeah, let me. I'm cheating. I'll admit. Sorry.
We have our cheat sheet here also if you want to check. I mean, this is my current implementation for the Light wallet, Bash Light wallet. But we want to go through the process from the scratch on this section. So
you know what? I don't want to call it just. I want to call it the root key. Create root key, just because. Yeah, private key is a little confusing, maybe. All right. So we can make this command nice and pretty as well. We don't necessarily have to pass in the. You deleted it. There we go.
No, it shows a deleted file. I don't know why.
It's that live share stuff. It likes to do stuff. Oh goodness. Before swallow enough. Okay, so with this, all right. So the next step of the process, right? So now we have our words. Ultimately, what we're really building here is an HD wallet, hierarchical deterministic wallet for to understand what the HD is, and this allows not just Cardano, but like Bitcoin, Litecoin, and Dash, and other cryptocurrencies to take your mnemonic and understand how to produce those deterministic keys, right? So by doing this, we're, ultimately we need to start the process. And to go maybe a little bit lower level with this, this is the transition from BIP 39 into BIP 32, and really BIP 34. So BIP 44, and please go research this stuff. They're open on GitHub, and this is what Bitcoin, BIP, so BIP. So BIP 39 is basically what we just did. We generated mnemonics. That is like how everybody, like every cryptocurrency, generates mnemonics and uses, basically turns your passphrase into a seed, right? That's all defined by the Bitcoin Improvement Proposal 39. So we all use the same words. Those words are basically set in stone. They're not random. To just be clear about that. So, we've done that. The next part is to understand how we can generate keys. So generating our private keys, and then how do we generate our public keys, and basically going down from parent to child to grandchild to great grandchild, all the way down, basically, and all that stuff. BIP 44 is the next step of that process, and defining basically how far you go down, what each level really means. And we'll get into that, but ultimately we need to start the process. We got to get our first key, essentially. So in this next oh, this might be interesting. Is Shelly still a supported option here?
Yep.
Oh, it is. Okay. Yeah, so basically what just happened there when he did that, it was expecting us to actually give it a mnemonic. That's why it was kind of just hanging. All right, so you can see there's a statement right there that says the recovery phrase is read from standard in. And that's what that initial part in the beginning is really doing on line 4 now. So it says cat, and it's accepting a parameter, and that parameter is your mnemonic. So the words that we generated, we need to give it to this command so it understands from which phrase do I create my root key from. And then basically, again, we're going to, well, first we have to tell like what type of wallet. So we can generate the Icarus. We can even generate a Byron wallet. But ultimately we want to generate that Shelly wallet. So from the recovery phrase, we're going to start basically a Shelly wallet. And what we're going to do is we're going to spit that private key out again to a file.
Yeah, we can skip. We can skip the wallet steer parsing for each script because it will be like part of a refactor of all this work, and that's what I have already done here. So yeah, for the test, we can just accept a couple of files, path files path. So we have our mnemonics here. Let's say we want to store our root key, private key here, or we use this type of names. See what we have here.
Cool. So, and then what we're looking at right here is this is the Beck 32 bit that really comes into play, because when we generate these keys, they're not really like this. This is basically base 32 encoding is really what it is. So you might have heard of base 64. So base 32 just has like limited character sets, and we have like this little prefix. And I believe if you want to know, for instance, why that prefix is used specifically, I believe it is the Cardano Improvement Proposal 5, so CIP 5, that defines all of these prefixes that we use for our addresses. But yeah, so for the oh my gosh, I just got hit up with Discord spam bot Ethereum giveaway. Awesome. But yeah, so Yeah, and that's great. I'm glad you did that. So what we're looking at there is a hexadecimal value of basically the key that represents our private key itself. And then that's what and there's there we go. Now there's the actual that's beautiful. That's the actual key there. So what we can do, and the thing is, at least with this particular binary, right, the Cardano-address binary, we're just going to work with our BEC32 addresses. I mean, it just keeps things simple, and
prevents you to confuse addresses from testnet and mainnet, because you don't want to end up sending mainnet ADA to a testnet address and lose it. So that's
right.
basically why we have this prefix.
That's a great point. And that's something else to kind of realize. Glad you said that, because with these keys, you can use the same mnemonic with both your mainnet and testnet, right? It really doesn't come down until you generate an address, right? A payment address that you actually declare the network. Until you get to that step, your wallet has no idea what network you're really talking about. So that's really important. Why not use the wallet API? So Rumorscape is asking us, why not use a wallet API? That's a good question, but there's limitations, right? If I want to use the wallet API, I have to run a full node. And I'm going to go with you're talking about specifically the Cardano wallet API. One, I have to run a full node, right? So that requires me to have a server that has a full node running. And not only do I have access to that node, but I have that running. What if I want to create a mobile light wallet, right? I want to have a wallet on my phone. I can't run a node, and it's really dangerous and very insecure to expose the Cardano wallet API through over the connection, like over the internet. So that is very ill-advised. So that's definitely a security thing to think about. But yeah, and it just really comes down to, what are the needs of, what you're trying to accomplish. Running a full node isn't always practical or possible. And yeah, that's my main thought process about whether or not I'm going to use the Cardano wallet API or not. And plus, what we're trying to do here is kind of explain the process of what Cardano wallet is doing for you. Because Cardano wallet uses the Cardano address CLI. So yeah, okay, the security bit when it comes to Cardano wallet, basically, let's say the main thing with that is let's say you wanted to expose the API, and let's say you're providing a service, and basically, the Cardano wallet, you don't have your keys, right? You have your mnemonic, and you put your mnemonic in. So let's say you've built this app and you provide a service, and let's say your node, right? Because this is specifically talking about building light wallets. Okay, so in the context of a light wallet, so this isn't a desktop app, right? Necessarily, it can be, right? Do you really want to hold on to people's keys for them? What if your server gets compromised? You just gave the hackers, or even if it's not even a hacker, maybe your server went down and you just lost all that data. You just lost everybody's keys. And if they don't have their mnemonic,
if you want a light wallet like that, you are really building an exchange.
Yeah, exactly. So it comes down to, how much security risk do you really want to expose yourself to? Do you want to be in charge of other people's keys? And that's what the Cardano wallet does, to understand. It maintains the keys in a SQLite database.
Locally,
so if you use locally, locally of wherever that particular binary is being ran. So if it's on your desktop like Daedalus, cool. You can go and explore your Daedalus SQLite DB and look at all your keys and all your transactions. It's all there for you to look at if you know how where those files are and how to explore SQLite. But if you want to provide something for somebody else, that's really what a light wallet is going to help you do. So,
right.
It's very flexible. Yeah, no, it's a great
So,
question.
So now that we have the root private key, we want to generate some public keys, maybe?
Yeah, all right. So this is where it gets fun, in my opinion, because more specifically, this is the whole BIP44 piece where we talk. It's like really defining what a hierarchical deterministic wallet, that HD wallet. Now, and the reason why I think this is where it gets fun is because Cardano doesn't necessarily follow BIP44 directly. I believe Byron was the actual real implementation of BIP44. But when we basically, since we have staking, we need an extra index, and we'll get to that what that index really is soon. But what we need to do, all right, so I'm going to, okay, real quick, the improvement proposal for Cardano that changed our hierarchical or whatever our HD wallet definition is SIP 1852, and that's about to come into play here in a second. All right, bear with me. I'm going to add the next command. All right, so actually, before I add this, Roberto, how do you so my next step in the process is to create the payment key, right? It's not really to create every layer. It's because ultimately,
Okay.
I mean, what we could do is go down to the account balance or the account layer and talk about why the account layer is actually important and why your ROI, at least from the last I've understood, your ROI goes down to there, and that's why even Lyft Wallet, we go down to the account level, and this is where we can start basically operating a wallet without the mnemonic.
Right.
And kind of like where your passphrase, like you have that spending password in your ROI, and why that's there. So yeah, okay, that's what is. I'll just go ahead and do that then.
Yeah. So Derive, for example, is storage your account private key, so it can generate payment secret keys and sign transaction for different accounts. But it can't recover the root private key from there. So it's like how to draw that or describe that is a bit difficult to me. But I guess if I wonder if the thick that's
all right. So I created a new file called Derive account, and I'm only going down to the account level.
oh wait, I need to switch that, right? Yep.
All right, so hold on one second. Before, yeah, as long as you leave the terminal up where it's at, I can. I want to describe something. So about halfway in, like basically in the terminal here, you can find where it talks about, Cardano address, key, child, and then it's like 1852H, 1815H, and OH. So there's these H's. I'm gonna share something in chat where you guys or everybody can just go and learn more about what it means to be Cardano HD wallet. In my opinion, this is super helpful to understanding what we're about to start talking about. So these are address derivations. Address is interesting in my head because really it's we're talking about keys and we haven't really gotten to the address part. And this doesn't really even talk about addresses. But anyway, so the first part is, okay, let's just talk about the H's. The H stands for a hardened path. Hardened paths, by definition, they require that you generate the child key. So that path, think of a path being a child. You need the parent key to get to that child or that path, right? they require a private key to be generated. So you can't take the parent private key, get a public key, which is how you get your addresses, and generate the next level down. So following the documentation that I shared in chat, ultimately, we have 1852, which is the purpose. If to really understand that, the first path is really talking about the cryptocurrency. Basically, you have Bitcoin and Litecoin; they all have their own purpose, essentially. So in SIP 1852, basically, I believe it was Sebastian kind of proposed that we use 1852.
Sebastian and Matthias.
Yeah, it's a nod to Ada Lovelace. 1852 is the year that she died. So that's basically our purpose in the path. The next is the coin type, I believe. Yeah, coin type. We use 1815, which that's the year she was born. And then we get to the account. Yeah, so specifically what Roberto has pulled up here is the Cardano Improvement Proposal 1852. What it really introduced is the staking key, which is the index of 2. So you can see in the chart there, it says external chain, internal chain, staking key. And you can see in the description for the first 2, external, internal chain, it's talking about, it actually references BIP44, and that's where those are defined. Your external chain, whenever you give out an address to somebody, right, for payment, to accept payment, what you just did was you basically shared one of your external chain public keys in the form of an address to accept payment. The internal chain is for when you send that funds, your wallet will use that chain to accept the change, right? So this kind of goes more into UTXO knowledge, where when you send a UTXO, right, your UTXO only has so much value and you don't break it up. Like, this isn't an accounting model like Ethereum, right? So when we send a UTXO, all right, here, let's just do an example. Let's say I have a UTXO that has 20 ADA in it, right? So hence that meant somebody sent me 20 ADA, right? So that's why I have a block that has 20 ADA in it. I need to send Roberto 15 ADA. In the transaction, right, he's going to give me his external chain address for one of his indexes. And I will send basically 15 ADA there. But what's going to happen is we also need to generate a change address, right? Because ultimately I only have a UTXO that has 20 in it, so we got to break it up. So that one input, that one UTXO input will be broken up into 2 UTXO outputs, one for 15 ADA and one for 5 ADA. The one for 15 ADA goes to his external change. The one for 5 ADA comes back to me on my internal change. So ultimately, that's how that works. So you have external, which is what you give people. Internal is how wallets deal with change and making sure you get back the remaining of the UTXO. And that works for everyone. That's how Bitcoin works, and Litecoin and Dash and all those.
And that your internal are called private. I think Yoroi calls them private addresses and tell you not to share them, although you can receive payments there, but it's for privacy. I mean, those are addresses that you never expose to the network nor to anyone, so no one knows that are yours. But yeah, you that way you can basically prevent anyone to associate your wallet and to track your balances. I don't know if I expressed that very well, but the reason for Yoroi to ask you not to share them is for privacy, for preserving your privacy.
All right, so got a question. What about the fees on the 15? Another branch for extended UTXO. Okay, the extended UTXO model, from my understanding, is ultimately it's kind of like an extension, hence it's extended, right? But it uses this model, but the extended part really hasn't come into play here. As for the fees, that is more or less a protocol thing. It's less of a wallet thing, actually. So yeah, it's like, you know, when it comes to like the protocol, right? Like Roberto, you can definitely probably have more knowledge on this one. So correct me if I'm wrong. Like with our fees, like we have a treasury model in place and all this stuff. So fees basically help fund that, and you know, our stake pool operators and stuff. So um, that's more protocol driven than wallet driven. Um, anyway, okay. To recap this real quick, the last bit, the staking key. This is specifically so you can stake your ADA and you know, basically participate in the Shelley protocol or fork, really. Um, so, and we can talk about a little bit more about uh, what all that means when we get to the addresses. But we will have to generate some staking keys, um, and we can. It'll be actually interesting to see that. Um, in fact, what I might do is, yeah, no, this is good. We should do it like this. I like, because this is actually, if we do the account based approach, we're actually demonstrating the light, like how a light wallet actually works. Because you can't actually, uh, in my opinion, do a light wallet without going the account based, right? So basically, now we're not going to do like a full um account, like how a light wallet should handle security, because there are other mechanisms in place. Like for instance, you don't want to actually store your account private key openly. You do want to uh,
Encrypted.
encrypt it, yeah, with a passphrase. And that's why, like for instance, in these wallets we have spending passwords, right? So you set that when you put your mnemonic in, because what's going to happen is it's going to basically go down to the account level, take that private key account key, and take your password, your spending password, and encrypt it with that password. So when you go to send ADA later, you put in your password, and it'll be able to decrypt and get what the actual private account key is. And then that's when we can, basically, that goes into the world of creating uh, like signing certificates, in which that is not, we're not going to cover that in this stream. We'll do that in the next stream. So yeah, we'll get to
Yeah,
it, but ultimately,
and also I wanted to like highlight that you don't really need to. This is the wrong. You don't really need to derive or use all the addresses from your account. You could make a very specific use case wallet where you just need or want, for the sake of simplicity, to handle one payment address and secret key. So you can imagine you want to have one mnemonics, but want to put one mnemonics that hold the whole balance for your cards fleet, and then you want to put just one payment address on each card. You could just generate one payment secret key, put it on a card, another in a different card, but no one will have the account private key that will access to the different balances for all the cards. So that will be a live wallet, a functional live wallet based on one address. That might be for simplicity, where you don't need to track different balances. The card just need to check one address for balance and doesn't need to account different paths and staking keys and all that. It's a really live wallet. I don't know if you have a better way to explain that, but
Are you talking about like incrementing your account index? Is that what you're referencing?
I'm trying to explain that you don't need to have 100 or 20 addresses on a live wallet by
Oh yeah,
necessity. I mean, that's something
yeah.
that Roy and Daedalus do because you want to preserve your privacy, but you can use these payment keys differently. Have devices that just hold one key that was derivated
Absolutely.
from the same private keys for a whole bunch of
Yeah. No.
devices.
Okay, I see what you're saying. That's a very good point. So, um, yeah, if you wanted to even make this even simpler, like he's saying, we don't actually have to we don't have to stop at the account level. And again, please look at that address derivation documentation to understand when I say like levels or paths or something like that. Even more specifically, if you look at the command up above, it says 1852H, 1815H, and then 0H, right? Like we can, like if I do this or not, yeah, right. So 0, right? We know from that one SIP that 0 is external. So we could generate this, and what we just generated actually, at least from right here, just what's highlighted, that is a payment private key, right? And then the rest of it right here, this is basically getting that public key, and from there we can generate an address, and that's what you would give somebody to accept data. So you don't have to stop like Roberto is saying at the account level. And if you want to make a very very simple light wallet, all you need to do is have that just one index of 0. So for instance, when you're Roy and Daedalus, and you want to go to your like receive ADA tab, and it has like a huge list of addresses. What it's really doing is incrementing the last 0, right? So, meaning, let's say I wanted to show 20 addresses to you. I would basically do this command, right? And I would do it with ending in a 0, then a 1, all the way up to 19. And that would actually give me 20 addresses. Now, the reason why, if you go down this path, you actually need to keep track of the private keys as well as the public keys, because in order to send ADA that you, let's say, accepted on index 5, you need to actually generate a private signing key from index 5, because index 5 is where you have that ADA that you accepted. So in order to spend it, you have to be able to sign from that key. So it's really important that, for instance, if you want to basically um, handle multiple addresses, is to stop at the account level, which is the last H. Notice how these last two numbers don't have H's. The reason for that is I can generate those levels from a public key. Those are known as soft paths or soft derivations. So I can actually go to the account level, save the private key, generate the public key, and then I have a private and public account key, and I can generate every key that you need in your wallet, whether it's an internal, external, or your staking key. I don't need anything else. So that's how a light wallet, such as your Roy's Chrome extension, doesn't have to ask you every single time you want to operate on your wallet for your mnemonic, because it has stored and encrypted your account level keys. So yeah, so then basically all they're doing is incrementing that last 0. That's how you're able to get multiple keys. But it does complicate basically how you send things, because you do need to account for it. Sometimes, what do they call it? Like address discovery or wallet discovery is another term for what I'm talking about. Like understanding, like if I have a wallet that's loaded on Yoroi and Daedalus, both of them need to basically understand, or at least kind of agree on the concept that, all right, I'm going to need to be able to handle discovering all of your UTXOs. So in the example, let's say you have a wallet and you only go down to 0, right? And but you've restored an older wallet that maybe Daedalus used at one point, right? And it has all these transactions on it. If you're using a really simple wallet that only goes to 0, you may not see all your funds, right? Because this simple wallet that only goes to the index of 0 isn't accounting for the fact that you accepted ADA on index 5. It's not going to look there. So it's not going to discover your UTXOs. It won't discover all of your funds. It does not mean you don't have those funds. You clearly still have access to those funds. You just have to use a different wallet to gain access. A while back, you know how ADA Light, I don't know if anyone saw this, but ADA Light came out saying that they're going to handle multi-delegation by using multiple accounts, right? So they're going to increment that H0 to 1H, 2H, 3H, stuff like that. That was a really important that was a lot bigger of an event than maybe most people realize. Everyone's just seeing, oh, multi-delegation, that's great. But the thing that people aren't really seeing there is that your Roy and Daedalus, they don't support that. They don't support H1. So if you go to ADA Light and you'd use multi-delegation there and you split up, let's say 1,000 ADA into 10 wallets, right? So in the end on H0, you only have, I gotta do math, 100 ADA, and then you go, even though you still have 1,000 ADA, right? You go to your Roy, you're only actually going to see 100 ADA. You'll never see that 1,000 because they don't support H1 and H2, the multiple account based delegation, which Sebastian from, well, I'm just going to say your Roy because he's not really with Emergo anymore, but he had a whole video on like the problem of multi-delegation, and that approach, the multiple account approach, was something he talked about, and he talks about what I'm talking about right now. So definitely go watch that. He does a much better job than I do. Long story short, this can be as complicated as you want it to be, or it can be as simple as you want it to be.
Right.
Let's see.
So this is in the end a consensus that we've decided, your Roy and Daedalus decided to follow, not to use like index 100 hardened account, but just use the index 0. And then it's the same for these subpaths, soft derivations. You could use just one address. You can track 20 addresses. That's up to you and how to use these addresses, but you need to take into account that if you use non-standard or paths that are not in this consensus, when you restore your mnemonics on your Roy or Daedalus, balances won't show up. That doesn't mean that are not there. They just don't account for these non-standard paths. Just in case you wonder what you will use as change address when you just use a single payment address, you can use your single address as change. That's something that came to my mind when speaking about this, just in case someone was wondering.
Yeah. You don't actually have to use the 1, right? Like you can just use 0, 0 the whole time. So what you accept from people and what you accept as change can still just be that 0, like that, and that external change or chain, sorry. Where 1, if you look into the improvement proposal, 1 being the internal change or chain. But yeah, and yeah, there's a whole nice story about me and Roberto working on Lift Wallet and dealing with UTXOs that and really having to like program wallet discovery. But yeah, so okay, let's go ahead and progress here though.
Yeah, maybe we can talk about consolidation at some other time.
Yeah. All right.
Rooming your addresses.
Do we want to? I guess we need to break up this Derive account into Derive account private and Derive account public.
Right.
But here's the thing. I realize that there's actually a better way of doing this, and it's not really worrying about I'm going to create two new files, and I think you can run with this very well. Oh, I messed it up. Oh gosh, no, I accidentally made a Haskell file. Whoops. That's a really weird like slip. I don't even write Haskell. I feel like Cardano just came into my blood and made me write that. I want to use the word here. Let's call it gen public key. All right. So we really can get rid of the Derive account. I don't think that's really important. But really, I think just deriving a private key and then generating a public key. Because then we'll just we can pass in the path to the private. That way it's a little more flexible, right? We can say like, oh, you want to generate an account? We'll just give us the whole account. You want to generate a public or staking, or we can do that. Here, I will get us going on that. Right, okay, so that. All right. I'm just going to get rid of the Derive account because we're not going to use that. Yeah, all right. So we have Derive private key. Oh, I'm sorry. I'm just going to throw parameters on here. Clearly, keep doing your thing. I like what you're doing.
Okay.
I don't know. All right. So while he's doing this, I want to just talk about that with chain code thing right there. That is that's a very interesting flag. You can actually generate these without chain codes. With and without chain codes is a very BIP32. Chain codes are kind of how you derive your private keys. They're definitely a part of the equation there. I definitely find it interesting that you can do it with or without. I will say it really, I think what they were trying to do is just be really flexible for the developer who is using this library. But yeah, I would say, one, I don't know if that's a valid. Can I hold on? Oh, I can. Okay, cool. I want to look at it. I don't know. I thought I read something that the whole chain code thing got removed. It did. Okay. No, it did not. Okay. Either way, we definitely want to do it with chain code. So I thought they removed it, to be honest. So getting like generating the public key is just this is actually where like real cryptography comes into play. Because Cardano uses a different elliptic curve than Bitcoin. And this is actually like generating the public key is where that really comes into play. Generating private keys, if I'm not mistaken, is not really about that. But yeah. All right, so Roberto's just making some really fancy parameterized scripts here.
Not that fancy.
Oh no, they're super fancy. All right, so we got our paths. All right, cool. So I would say let's just go ahead and create basically, let's just skip the account thing. We can definitely talk about that at a different place. Please X the marketplace pop-up. Oh, your bottom left or bottom right pop-up on VS Code, yeah.
See ya.
Oh, yeah, okay. Yeah, the account stuff is more or less like, to me, it's more software oriented than it is actually wallet oriented. But it is very much a light wallet thing to do. So I would say let's just go ahead and, you know what? I'll make little comments. Is it pound? Pound's a comment, right?
Yep.
Cool. Ah, not JH. I'm gonna get there, guys. It's almost, yeah. So there's that one and that. Okay. And this is, so these are really the two very much important ones. I don't really even think, like, bare minimum for staking.
Right. So we try to derive the private key for the first payment address.
Yeah, I say go ahead and do that, and then we can do the staking. And then we can.
This is our root private key. We want to derive this path, and we want to store that secret private key as payment 00 private payment 00, for example. Okay, this should be
Cool. All right, so that is our index 0 external payment key. And I would say go ahead and create the
public
stake. Yeah, definitely. Yeah, we want to create the public key for this, and we also want to create the private staking key.
This is the private stake. That's it.
And just keep noticing how, like, for instance, the stake key is stake underscore, and then the payment address is ADDR underscore. Again, these are just prefixes to the, and then like the XSK. So that's your private key is what that's really signifying.
Do we want to show how to generate from the same account private key? From the same root private key a testnet address?
Yeah, I would say like we can get the public keys first, and then we can generate our addresses from them.
Okay.
Mainly because we can talk a little bit about, because it's really interesting in my opinion. For instance, generating a for instance, it's very specific on how you generate your staking, or like, it's basically, they're known as, it's the enterprise address and your delegation address. We don't ever call them these things, and I would say most people, unless you're a stake pool operator, you've probably never even seen an enterprise address. Delegation addresses are just the standard, and you just know it as a payment address. It's what you accept ADA from. But ultimately, just know that there are multiple types of addresses coming even from the same path, even from the same like payment public key, that you can generate multiple addresses and accept ADA from, but they end up affecting the protocol a little differently. So like, for instance, like your reward address, you can get like the same, payment address and reward address can come from the same public key. So there is a difference between like keys and addresses. So just to kind of keep that in mind. I would, if you can, what do we need for, 1 second. Do we need the staking? I think we need the staking public key too.
What for?
Oh man, I didn't make a note. So like for instance, like if you generate a payment address, so like here, I can use your terminal. So this is what I'm talking about. Let's explore. Cardano address. I think it's address. Okay. So waiting for Twitch to catch up. All right, cool. So we have payment, stake, and delegation. Pointer is another one. I'm surprised script isn't here. It doesn't matter. Okay, so when we generate a staking address, we're going to use the stake. So for instance, if I do, all right, we need public keys, but it doesn't matter. If you generated an address, a payment address, so like available commands, right? I did, Cardano address. So we're going to generate addresses. But there's a difference between a payment and a delegation. So if you generate a payment address, that is going to generate what is known as an enterprise address. And if you accept ADA, so let's say you're delegated to a pool, right? You know how the notion is that if you accept ADA, that ADA is already delegated automatically for you. You don't have to do anything. That's because what you're using is a delegation address. You're not using like the standard payment address. The payment address that is described here is known as an enterprise address. And if you accept ADA on an enterprise address, your ADA is not delegated to a pool. That's the pure purpose for it, is that it cannot be delegated. Enterprise, I guess the whole notion is that companies who want to deal in ADA, they don't necessarily want to stake the ADA, which, I mean, if you look at any company that deals with ADA, like, let's talk about an exchange, right? You have, like, these are big companies. So like Binance and Coinbase, they're clearly staking their customers' ADA, right? So I mean, I don't really know who would use this, like what the benefit of, kind of openly saying like, hey, we don't delegate your stuff. I mean, I think that would be a good PR, standpoint to take, but you would have to generate those type of addresses to guarantee or prove to the network that you're not doing that. Ultimately, another thing to think about too is just basic user understanding. So like your standard cryptocurrency end user using a wallet. I can't remember where I read this. It might have been on the Cardano forums. Basically, Sebastian was talking about, like why just generating the delegation address is the standard way to operate, versus, like here's a payment versus a delegation. It really just comes down to just keeping it simple, right, for the end user. Like there's no point really trying to describe these differences and making sure people know what they're doing. It's just kind of like, we'll just basically take it on behalf of ourselves and just make sure that you don't make this mistake, and that every time you accept ADA, it'll always go to your delegation. But yeah, that being said, in order to make, okay, so I'm just gonna run. No, this is gonna be too hard for me to run with this. Can you go ahead and make the public keys for both the public and stake private keys that you just made? So we need the public keys to make addresses. We cannot make a payment address from a private key.
So yeah, let's do first the stake one. That should be enough. There it is. That's the public stake key. And that's the public key.
Awesome. So yeah, now we can create addresses. Let me just check my scripts real quick.
You don't like mine, huh?
Well, no, yours are good. Yours are way more fancy than mine. Mine require to understand what 1, 2, and 3 mean. Okay, so
To be honest, I need to revisit the Cardano address as help each time I go through my scripts.
oh yeah, 100%. All right, so I'm gonna kind of just do this real quick. Oh, come on.
Cardas, yeah.
Oh, come on. That's welcome to the live share. Welcome to live sharing. Okay. Okay, so we don't need the I don't know why I thought we needed the protocol magic. But yeah, that's
To
oh,
generate the testnet address. Yep.
just need the
Well,
tag.
yeah, the tag.
Okay, so but that's a really good. I like how the address does the full example there. It's just like you don't need to break it up every step the way we are. Okay, so I would say the best way to go basically to accept ADA. Now, what we can do, right, is we can say, I'm gonna try to scroll up here. Could be wrong. I mean, this may not work. I'm using Twitch because the terminal doesn't really like to play.
Oh, do you want me to
nicely.
try it?
Maybe in a second. Ah, it didn't work, I don't think.
You miss it echo.
Yeah, okay. Oh, okay.
Oh, man. Something else.
There we go.
Payment, and yeah, you need to.
Yeah, we can just do standard input with the wallet. Oh, okay. Yeah, that's it. All right, cool. So what we just did there, now I'm really glad you did it. Notice how short that address is, right? Like no one probably sends out payment addresses to accept ADA that are that short. And that's because what we just generated is that enterprise address. It's not, you can accept ADA with this, you can spend ADA with this that you've received through it. But when you do, you will not delegate any of the ADA that was sent to that address. That's why we have, yeah, we're just gonna start from scratch again. Data, address, delegation, can't spell delegation, is the delegation address. And what we see here is that it actually it uses the stake private key. No, the public key. I was about to say. Okay, so when we execute the delegation address, we actually incorporate the staking public key. So that helps the protocol know that when you accept ADA with this type of address, that it knows how to redelegate it automatically. So that's the difference between your standard payment address that is really an enterprise address that you cannot delegate with, and what everyone knows as the payment address is really a delegation address. So yeah, ultimately, no point making enterprise addresses. I say that we go ahead and get our testnet delegation address and then go to the faucet and receive some ADA.
That's good.
Wait, do we want to make a script? Yeah, we should make a script. Here, I got you.
We can generate it again. Do you have the URL? Oh, okay, got it. So I will share my browser, but I don't trust OBS. Last time I messed changing the screen I shared, it broke, so I'm just entering that testnet address on the faucet. I will leave the URL in the chat. We should receive some data. Testnet data. You're mute.
Are you using that address?
Yeah.
Okay, so you're using an enterprise address. So that means we cannot delegate this ADA.
Right.
Just throwing it out there.
Okay, and this is when the light wallet skills need to come in place. How do you query for balance for an address that is not without having a local node to query the address, to query the blockchain?
Yep. So what I personally do, right? So that's a good question. So when building a wallet, you either have the node and you can talk to the network directly and get some UTXOs based on an address, aka the address that you accepted ADA on, or let's just talk specifically with what IOHK offers, right? There's the Cardano GraphQL, right? So if you have GraphQL hosted, you can make a GraphQL request and get your UTXOs. You can use Cardano DB Sync, right? So if you got that set up, that also both of these require full nodes. But the concept here is that these are basically you don't have to worry about compromising other people's keys, right? So it doesn't matter if you have the GraphQL library up or GraphQL library, the hosted service, which requires DB sync in a full node, right? So you still have to have that full node. It's just you can now have it away from your wallet, and they don't have to be together. Luckily, Roberto has a very nice service called Dandelion, and we can just go look at our UTXOs using the Dandelion playground.
Okay, in the end, I'm gonna risk the stream.
Well, can you just use curl?
Yeah. Yeah. Let's do that.
We're bashing, man.
That's my environment.
Yeah.
So I might have some query handy around here. Okay, let's start by establishing an environment variable for the address we want to query, and then we can use this query for GraphQL. So if I like to write files.
Oh, you may need to drop the token stuff. Just a heads up.
Oh, that changed, right? Okay.
Let's just put it this way. It worked when I got rid of tokens and then the object per token.
Oh, look at this. I have already a query in TMP folder.
Oh, that's perfect. Yeah, that's so. What you just saw there was a GraphQL query that will basically we're sending to the Cardano GraphQL service that anybody can host, right? It's just that Roberto has a service called Dandelion, which kind of spins all of the mechanisms up, all the dependencies. So again, the Cardano GraphQL service project relies on two other projects, which is the node and Cardano DB Sync. So there is some
so we
know-how.
We could use this JSON query. No, it's not exactly JSON, so I cannot JQ that,
Yeah,
but
it's
this is the
very
GraphQL.
GraphQL.
Yeah, this is a GraphQL to get the balance for the UTXOs for an address. If I got it right, so now we need a GraphQL endpoint. I will grab, and we
Put it
should
in
be
chat if
able
you
to
want it.
do. I think that's enough. Oh, nope. What I miss?
Do you need to? Oh, you need to post it. So -x post.
When you passed, the that should be enough. Ah, right, headers. I think it needs headers. That's what happens when you, yes. Ooh. That means we messed it up with the query.
Oh, here you go.
Yeah.
I wonder if this will paste beautifully in. All right, that should get you probably enough where you want to be. Pardon the messy. So I copied my my curl straight from Dandelion Playground. So you should at least be able to get what you need out of it.
Oh. Okay. Paste it.
I'm sorry. I guess I could put it in the code right there for you to grab, huh?
Just paste it on the terminal.
Oh.
Okay.
Yeah, I can do that. I don't know why I didn't think to do that.
Let me prettify this. Let me prettify it a bit more. That's it. Yeah, this way the query is a bit less readable. And I know what happened. You need to include this slash and for curl to accept for GraphQL to accept the query. It's tricky to do the curl to forge the curls manually. But yeah.
Either way, so what we're looking at here, right, is a UTXO. That was basically where Roberto went to the Cardano test faucet, and he has what is that? It's 1,000 test ADA.
Yep.
That gets sent. So you can see what block number it is. You can see the transaction hash. So if we want to pull up a testnet explorer, we can see that hash.
Right. And if you actually, I think I cannot request more ADA until tomorrow.
Roberto, did you defocus the Google Meet? Because my face is frozen.
Oh yeah. Sorry.
I'm just an avatar. That's all that's going on. There we go.
Yeah, so if we request more ADA or send more ADA, as you can see, UTXOs is an array, and it includes a transaction. It will include another transaction for this same address, and the balance for that address will be the sum of the two entries in this UTXOs array. I don't know if we can do that from the faucet. I think I do.
There you go. I posted a link to the Cardano testnet block explorer with that transaction, and you can see how we accepted 1,000 ADA.
Yeah,
and
I cannot request
an address that has 9.67 million test data. So
I cannot request more data from the faucet, but I can send some more from an address of mine, so we can check a couple of UTXOs, so we can illustrate what how a wallet will calculate balances. I'm on it. And that's I mean, one of the challenges for using many different addresses is exactly this: how you calculate the balance. You actually need to query all the addresses you use and sum the balances, the different balances. And if you use like 1000, it will take time because you need to request the UTXOs for 1000 addresses.
Yeah, exactly. And that's I think honestly, I think that's, to me, that's kind of like the interesting part of the wallet, and I think that's where things can get you know, pretty interesting. You know, if wallets allowed you, you could actually get very particular about the way you spend your ADA. Um, Almost like saying, you know, always accept on this address. Um, but you don't really necessarily, and if you have a different address that has other ADA too, so it's yeah, you could basically accept ADA on one address and always spend from that one address as long as it made sense for you versus others. So I mean, yeah, so there you
Yep.
go. So he sent more.
For example, if you want to build a very specific use case wallet or application, and you don't want to deal with the overhead of calculating the balance from different addresses and all that, you could use just one address and just sum this array, and you're done. You're done. It's much more easier than a full general purpose wallet, let's call it. For example, for the C64 Minter wallet, if you just want to use that wallet for minting tokens, do you really want or need to have different addresses? Maybe not. That's probably the approach Jaime is gonna be using. You have an address, there is where the minted tokens end up, and that's it. You don't need to deal with all these other problems that are involved.
That's a great point. You know, and I know A has talked about the concept of a throwaway wallet, or maybe not necessarily throwaway, but even just something on the sense of like a burner wallet, or something where, you know, it may not be useful to you until you reach a certain balance, where then you can, you know, then really establish something that's a little more recoverable, basically.
Yeah, the only problem with the throwaway wallet, it's probably dust. It might be difficult to leave the wallet at exactly zero balance. So
Oh, what are you talking about? We know how to do that. Just, that was a very interesting feature for Lyft to implement.
Send all.
Send all, yeah. All right. So we covered what it means to basically, you know, get your mnemonic, take that mnemonic and create your root key, derive private keys from the your root key, and generate your public keys from the private key, and generate an address where we accept data. So, you know, in my opinion, we are halfway done with what it means to build a wallet. The next half is basically spending it, right? So like, it's kind of might be a little pointless to accept data if you can't spend it. So in the next part of this series, so the next stream, we will discuss spending ADA, or basically building a transaction, signing that transaction, And the very interesting part of a Light wallet is how do you submit that transaction if you don't have a full node with your wallet? But I feel like we kind of lent ourselves or exposed the potential way for using Dandelion and stuff. So yeah, this is definitely a fun topic for me. So very excited about creating this series.
Yeah.
But yeah,
So
if anyone has any questions, we'll definitely put this up on GitHub. You know, they're very rudimentary commands, but you know, I think the repo along with this video will be helpful. And if anyone has any questions, you know, jump on to the Gimbal Labs Discord, hit us up. We're always open for discussing light wallets and how to manage funds. And maybe you can hear me go on a rant why I think wallets is a horrible name for this, because there's so much more you can do with keys and addresses than just hold funds. Okay, yeah. Okay, so A asked a question. Would it be helpful to hear your thoughts on beyond full node versus light wallet to why on-chain versus off-chain checkpointing implementation possibilities? Okay, so Roberto, that's really you. That's I don't know. That's a hard basic. Okay, so is this okay? So if I correct me if I'm wrong, A and Roberto, but this is the notion where you don't have to have the full blockchain to operate, right? Like you can have checkpoints. So there could be like a hybrid wallet where you have the chain, but only up to a certain point, and operate based off of a like partial chain, right? Is that what we're?
I'm not sure what exactly he want to dig into it, but yeah, I will try to tackle the question and make some reflection about the on-chain off-chain thing. So if you have a full chain, full node, you probably have waited like hours sometimes, depending on your connection, to let Daedalus sync the full chain to the tip, and you probably got scared because you opened it up and it was syncing and it was showing zero balance because somehow the chain that was in your computer got corrupted, so Daedalus needed to start syncing from the scratch. So suddenly you saw zero balance until it reaches the point in the chain where actually your balance was included to your addresses. So in the scenario of a light wallet, you depend on servers that has this chain. In our case, Dandelion runs a full node. Then you have DBSync, which imports the data from the full node into a Postgres database. And then you have GraphQL that queries that database. And so you have 3 different points of failure on that chain of software. And if any of those are out of sync or down or whatever, you get to the same point that when Daedalus has a corrupted chain locally, when you cannot check your balance. And that's what happened, for example, when your ROI backend services crashed because the heavy load these NFT sales put on their servers, and you have your wallets synchronized on the browser extension, and you keep a snapshot of your balance. In this case, it's not like in Daedalus. Your ROI saves like the last balance in your browser, so you don't really see zero balance and get really scared. And yeah, those are like the different scenarios and problematics that you have with a full node versus a light node relying on standard servers for checking balances and operating. I mean, if your full node in Daedalus is not up to date, you cannot send ADA because well, you can submit the transaction, but it won't be a valid transaction probably because you don't have the actual real status of your wallet. So yeah, that's
Yeah. So A is just asking like really interesting questions. I think this might end up being like one of our like Gimbal Labs, what do they call it? Like conversations or something. These are. I feel like there's a lot more maybe like supporting mechanics that you would need to do in order to accomplish like an off-chain wallet. Because I've part of me is almost like screaming like the sidechain stuff, where it's like you can operate outside the chain but then reconcile later type thing.
I think Rosetta API can do that. I mean, somehow you keep the same that I mentioned with Yoroi. You save local state on your database. From that, you do your calculations on. I mean, if you know the balances for your addresses, you can do the calculations for the input, the transaction inputs and the transaction outputs. So you can build a valid transaction, sign it, send it to a queue that will reconcile with the blockchain whenever it gets connectivity. And Rosetta API does that job very well. I mean, it's designed for that. You send transactions to Rosetta, and it will try and retry to send it to the Cardano node whenever it's available. So yeah, that's an interesting idea feature that I don't think anyone is currently implementing. We planned to do some experimentation with Leaf Wallet and Rosetta API, but we never managed to do that session. So maybe it's a good session to do soon.
That would definitely be multi-part there. That is for sure. All right. All right, cool. I figure we can call it here. But again, yeah, if you guys ever want to talk to us, jump over to the Gimbal Labs Discord. We're always up for tinkering, just brainstorming, doing thought experiments around this stuff. But yeah. Yeah. Oh man, Plutus. Yeah. We'll think about it. Even as I'm a programmer, and I'm hesitant to walk the Plutus plank. Learning a language it's very time consuming, especially when you don't get to use it like professionally. Yeah, it's like I've learned. I taught myself Rust as a hobby, just because I like the syntax. I liked kind of like what it allowed me to do. But it's like one of those things where like if you don't constantly get to use it, at least for me, like I'm a professional, professional whatever programmer, but like having to constantly kind of live in your career language and then come out and try to program in a different language, you kind of will lose context a lot of the time, just trying to maintain the progression of like hobby languages. So
that's me all the time. But I encourage anyone looking for great Plutus content to check Easy Staking, Easy One YouTube channel. Giovanni is doing a great job doing his homework from the Plutus Pioneer program. He's doing a very similar work than us here, like going doing shameless programming live. That's a cool a cool channel to check if you are looking for some Plutus content.
Yeah, he's yeah, definitely. I watched his first video over the first Plutus homework. It's really, you know, it's a good approach for kind of just exposing, you know, like what Plutus is, especially, I mean, you know, he has I don't want to say he has a similar background, but he has like some similar experience with functional programming. But I mean, he's not a Haskell programmer, right? He does Java and Scala.
Yep.
So I mean, like you know, he dabbles in functional, but I think yeah, his channel would probably be really good if you want to learn more and watch a programmer tackle that type of stuff. So for sure.
Yeah. It would be cool to have him on board at some point.
Yeah. Yeah. Oh man. Yeah. He should totally come on and maybe he can school both of us. That'd be great.
Okay.
Right, well, I need to head out. I think this was fun. And I'm looking forward to next week when we can spend some of this ADA. So.
Yep. See you everybody, and thank you for accompanying us.
Yeah. Thank you. Y'all have a good one.